Welcome to the GeoMethod channel. Today, we are solving another interesting geometry problem. Here is today's challenge. Can you find area of the blue rectangle? Take a moment to study the figure. Then, let us uncover the key geometric ideas that make the solution click. Here is a blue rectangle ABCD, with A and B along the right and D and C along the left. Our goal is the area of this whole blue rectangle, and everything else in the figure is there to help us find it. The segment DE runs from the top left corner D across to a point E on the right edge. It slices a triangle ADE off the top right corner, and because A is a corner of the rectangle, this triangle has a right angle at A. Everything above segment DE is the corner triangle. Everything below is the trapezoid EBCD. These two pieces together make up the entire rectangle, with no overlap and no gap. The figure tells us the two areas in a shared unit A. The corner triangle ADE is 2A, and the trapezoid EBCD is 3A. So the pieces stand in the ratio 2 to 3. Two lengths are also marked. The slant segment DE equals the rectangle side CD, and the little right-hand piece segment EB has length 1. We'll lean on both of these later. Let us give the sides names. Call the width segment AB, which equals segment CDX, and call the height segment ADY. Once we know x and y, the rectangle's area is simply x times y. Point E sits on the right side, and the piece segment EB is 1. So the upper piece segment AE is the whole width minus that one. That makes segment AE equal to x minus 1, which is the short leg of our corner triangle. So the number we want is x times y. Our whole job now is to pin down x from the area ratio and then pin down y from the slant condition. Because the triangle and trapezoid fill the rectangle exactly, their areas add up to it. So x times y equals 2a plus 3a, which is 5a. That's our first equation. Triangle ADE is right-angled at A, so its two legs are the height y and the base x minus 1. The area of a right triangle is half the product of its legs, giving 1/2 times y times x minus 1. But we were told that same triangle is 2a. Setting the two expressions for its area equal gives 1/2 y times x minus 1 equals 2a. That's our second equation. Here is the clever move. Both equations carry the unknowns y and a, which we don't want. If we divide the triangle equation by the rectangle equation, both y and a will cancel, and only x will survive. Write the triangle area over the rectangle area on the left, and 2a over 5a on the right. The two ratios must be equal because each side is the same fraction of the rectangle. On the right, the a's cancel straight away, leaving the plane number 2/5. So the triangle is 2/5 of the whole rectangle. Aha! Divide the corner triangle area by the whole rectangle area. The shared height y cancels, and the unknown area unit a cancels on the other side, so the geometry reduces to one equation in the width x alone without finding the height first. Putting the two cleaned up sides together, we get x minus 1 over 2x equals 2/5. This is a single equation in the single unknown x, exactly what we wanted. Clear the fractions by cross-multiplying. 5 times x minus 1 on one side, and 2 times 2x, which is 4x, on the other. Now there are no denominators left. Distribute the 5 across x minus 1 to get 5x minus 5. So the equation reads 5x minus 5 equals 4x. We're one step from x. Subtract 4x from both sides and add 5, and everything collapses to x equals 5. So the rectangle's width is 5. Aha! The given equality segment DE equals segment CD transfers the rectangle width x onto the slanted hypotenuse segment DE of right triangle ADE. With segment AE equal to x minus 1, Pythagoras now determines the remaining height without exposing the final area early. In a right triangle, the squares of the legs add to the square of the hypotenuse. Here the legs are y and x minus 1, and the hypotenuse is x, so y squared plus x minus 1 squared equals x squared. We already know x is 5, so x minus 1 is 4. Substituting y squared plus 4 squared equals 5 squared, that is y squared plus 16 equals 25. Subtract 16 from both sides to get y squared equals 9, and taking the positive root gives y equals 3. So the height is 3. Now we have both sides. The blue rectangle's area is width times height, 5 times 3, which is 15. Let us check with the A units. The corner triangle is 1/2 of 4 times 3, which is 6, so 2A is 6 and A is 3. Then 5A is 15, matching the rectangle exactly. Everything is consistent, so the answer is 15. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.